Hello and welcome to our magical molecular mania. As you can see, we are both witches. I'm Ashlyn.
And I'm Cricket.
So today's Muggle Studies lesson will be on magnets. Oh, just in case you were wondering, a Muggle is someone who is not a witch or a wizard. Okay, so when many people, witches, wizards, and Muggles alike, think of magnets, they picture their refrigerator covered in magnets. However, magnets are found everywhere in the Muggle world, from everyday items like video game consoles and cell phones to larger items like cars and airplanes.
Whoa.
Yeah, magnetic interactions are so important because, Cricket, did you know the Earth is one giant magnet?
Oh, yeah.
Yeah.
We should tell them about that.
Yes.
Oh, man.
Oh, my gosh. That's why we're so interested in learning more about them.
Yeah. Some magnets last lifetimes, while others last only for a few seconds. So take these bar magnets here, and they're like the magnets that you have at your fridge at home. And bar magnets, they actually last for a long time, and they have what we call poles. One end is the North Pole and the other is the South Pole, just like what the Earth has, making the Earth one big magnet.
Wow!
And it's really interesting because the way that our poles interact is that opposite poles attract each other, while poles that are alike repel each other.
They really don't want to get together, do they?
No, they don't.
So, since the Earth is a giant magnet, we can use smaller magnets in these Muggle contraptions, shown here, called compasses, like so, to detect the Earth's magnetic poles and thus find the directions we want to go. This is just like when Muggles use a GPS on their phone or in their car.
Oh, wow. So, why is Earth a big magnet? We kind of mentioned this earlier. Well, inside of the Earth, the core is made up of molten metal, mainly iron, that's naturally magnetic. Here we've brewed this liquid called ferrofluid. This magnetic liquid, it has small metal magnets inside of it. I'm going to take some out of here and put it into a smaller container so that we can look at it. And when we interact the ferrofluid with our bar magnets that we saw earlier, we see that there's tiny little spikes here that show up with our magnets. That's the metal that's the metal particles inside reacting with the other magnets.
That's so cool!
So there seems to be something afoot here. Do you think that there's magic? Do you really think we're witches? Well, in Muggle studies, we learned that there are all types of magnets, ones that work at room temperature and ones that work better at colder temperatures.
Cricket, do you want to show them that spell that we learned in Charms class, but it only works at really cold temperatures?
Oh yeah, you're right. But of course, however, we need help from you to make this work. So everyone, you have to grab your wand. A pencil will work in a pinch, so pause your video if you need to go find one.
All right, everyone. Now, every spell has special words in order for it to work. Listen carefully because you must pronounce it correctly or else the spell is not going to work at all. Follow after me. Wingardium Leviosa. That's right. Wingardium Leviosa, not Leviosa. All right, it's your turn. Smashing! That was so marvelous, wasn't it?
It was very good. All right, now we need to learn how to handle our wands correctly. I'll show you and then you have to do it yourself. So when saying our spell, you want to swish and flick the wand. All right, go ahead, swish and flick. It's all in the wrist, dears. All right, so I'm gonna show you now how to say it with our words that we just learned. So we're gonna go, Wingardium Leviosa. All right. So I think they're ready. So we need to, on the count of 3, we're going to perform our spell, all right? 1, 2, 3. Wingardium Leviosa. Good job, we did it. Look, it's really floating.
Gosh, look, it's spinning in the air. I can even make this piece of paper go underneath it. Oh my gosh. Look at that, so magical. Now, do you really think we're witches?
That's right. No, we're not witches, but sometimes it's fun to pretend. In reality, we're scientists.
Hey, would you like to learn a new word? This disc that you see here is called a superconductor. Can you guys say that with us?
Superconductor.
This is a special magnet that is very strong, that it can repel other magnets, such as the cube you see here. but it's very strong and it only works that way at really cold temperatures.
Oh, wow.
Yeah. So, superconductivity causes a repulsion of other magnets, like this cube magnet we see here. So strong that we see the normal magnet floating in the air above the superconductor.
Wow.
So magical.
Magnets are everywhere, even ones that must be kept cold, like this superconductor.
Yeah, I mean, you can find them in, windmills, even in levitating trains.
Wow, I didn't know that.
I know.
What you see here around it is liquid nitrogen, and this reaches temperatures of -210 Celsius, or if you translate that into Fahrenheit, -346 degrees. So cold that it would hurt if you touch the liquid that is surrounding this magnet with your bare hands. So to protect ourselves, we use these gloves. These are cryogenic gloves that are made from special materials that are able to resist really, really cold temperatures.
Yeah, and you'll notice we're also wearing these fabulous safety glasses. These protect our eyes, and we also wear lab coats. These protect our bodies from any accidental splashes.
We hope you've enjoyed this adventure learning about how magnets influence our everyday lives. Remember, science is magical, explaining phenomena that are all around us in ways that we never knew.
To see other cool science in action, check out our other Molecular Mania videos. Happy Halloween! Ooh.